Hello, everyone, and welcome to today's masterclass on OCI streaming services. I am very excited to be here today, and we all thank you for joining us today. A quick intro about me. I am Simi Joshi, part of Oracle for Startups Marketing and Events team, JPAC. Before I invite our speaker to present today, let me introduce him to you all. Mitesh is a senior cloud architect with Oracle. Mitesh has essayed different roles, including enterprise architect and migration manager. In his free time, Mitesh promotes cloud technologies as cloud advocate and loves to play badminton. In this masterclass, he will introduce you to streaming services and how to set it up. Hope you find this session insightful. And if you have any questions during the session, just pop them in the Q&A window. Over to you, Mitesh.
Thank you, Simi. So here at Oracle for Startups, we work closely with startups in enabling them to build enterprise-grade applications on modern cloud technologies. And one of them is OCI streaming services, which we are going to talk about. Hello and good morning to everyone. My name is Mitesh Vipale, and I'm the Senior Product Manager with Oracle for Startups Global Program. I'm really delighted and honored to conduct this masterclass with you guys today. So in case you all don't know me yet, I'm associated with Oracle for Startups for last 2 years, and I also play the role of cloud evangelist. You can find me on LinkedIn on the link given below. Next slide, Simi. So agenda is pretty simple. We are going to talk about OCI streaming services, and we'll do a short demo on OCI streaming services. We are going to talk a little bit about Apache Kafka architecture and OCI stream metrics. So we are going to cover a lot of topics in a small time frame. And I would encourage everyone to drop your questions in live Q&A chat box, and we'll try to answer as many questions as we get forward. But in case if there is a question which requires some kind of extra information or conversations or different kinds of links which are required, I promise that I'll get back to you over an email or by a Zoom call. So having said that, let's get started. Next slide, Simi. Okay, so what is streaming? So streaming service provides a fully managed, scalable, durable solution for ingesting and consuming high volume of data streams in real time. It is also used for other use cases in which data is produced and processed continually and sequentially in published subscribed messaging model. It is used for messaging. So it is used to decouple the components of large systems, such as producers and consumers use streaming as an asynchronous message bus and act independently at their own pace. The next one is metric and log ingestions. It is also used as an alternative for traditional file scraping approaches to help make critical operational data more quickly available for indexing and analyzing and visualizations. It is also used as a web or mobile activity data ingestions. So what do you mean by that? So streaming is used for capturing activity from websites or mobile apps such as page views, searches, or other user activities. It uses this information in real-time monitoring and analytics and in data warehousing system for offline processing of this and to report these data. Next one is infrastructure and apps event processing. Streaming is a unified entry point for cloud components to report the lifecycle events for auditing and accounting and related activities. Next slide, Simi. So there are different features which are used for streaming, which we are going to talk about. Streaming provides a lot of different features, which are first one is fully managed. So streaming is a fully managed from the underlying infrastructure to its provisioning, deployment, maintenance, and security patching and replications. Integration with monitoring and default metrics makes operations really easy. Oracle manages stream partitions and consumer groups handle message offsets. Next one is durability and availability. So message published to the streaming service are synchronously replicated across 3 availability domains when available. If the region has only one single availability domain, the data is replicated across 3 fault domains. Next one is security and reliability. So streaming data is encrypted both at rest and in transit, ensuring maximum security for the streaming data. So Oracle managed encryption keys are used, or if you want to use, you can use OCI Vault service to securely store and manage own encryption key if you need to meet some specific customer requirements. The next one is integration with OCI identity and access management. So IAM facilitates to control who and which services can access keys and what they do to the resources. Private endpoints restrict access to the virtual cloud network within the tenancy, so the streams cannot be accessed throughout the internet. The service uses synchronous data replications such as geographically distributed availability domains for fault tolerance and durability. Streaming is also backed by 99.95% service SLA. So what do you mean by that is Oracle will provide you credits if any breaches of this SLA. It provides tenancy level data isolation and eliminates noisy neighbor performance issues, irrespective of the scale and usage. The next one is it will also provide Kafka compatibility. So it is compatible with most Kafka APIs, allowing to use applications written for Kafka to send message and receive messages from the streaming service without having to rewrite the code. It also takes the advantages of Kafka Connect ecosystem to interface directly with the first party and the third party products by using Kafka source and sync connectors. You can see it in the screenshot given, where the first party and third parties are connected via using Kafka source and sync connectors. So streaming Kafka compatibility significantly reduces window locking and helps customer to easily adopt, and it also gives an hybrid and multi-cloud approach. So customer with the existing Kafka implementation, whether deployed on-premise or on other clouds, can easily migrate to streaming by changing a few configurations parameters. Next slide, Simi. So streaming concepts. So there are different streaming concepts. We are going to discuss most of the concepts later as we proceed in this webinar. The first one is stream. So it is a partition append log only message. So it is an ever growing data set where new records keep arriving. Next one will be stream pooling. So it is a group that is used to organize and manage streams, including any shared Kafka or security streams. Next is a cursor. It is a pointer in a location in a stream. Location is appointed to a specific offset or a time in a partition or to a group's current location. Next slide, Sami. The next one is partition. So what do you mean by partition? Partition is a section of a stream. So each partition is typically placed on a separate virtual machine in order to provide durability of data. It also allows multiple customers to read from a stream in parallel. Each partition can be hosted on a different server in different ADs within a region, which means that a single topic can be scaled horizontally across multiple servers to provide performance far beyond ability of a single server. The next one is message. So it is a base 64 encoded message that is published to a stream. It is used to create new messages. In general, a message is returned to a specific topic. If you come from a database background, think it as a row or a record in a database. Next is a producer. So it is an entity that publishes message to the stream. Next slide, Simi. The next one is consumer. So it is an entity that reads messages from one or more streams. A consumer keeps tracks of which messages it has already consumed by keeping track of message offset. The next one is a consumer group. It is a set of consumers that coordinate to consume messages from all partitions in a stream. Each partition is consumed only by one member of the group. Next slide. So what is a topic or a key? So it is a group of related message. Think topic as a database table in the database language. Next is instance. So it is a member of a consumer group. Instances are defined when a group cursor is created. Offset. So the location of a message within the partition. Each message within the partition is defined by its offset. Consumer can read messages starting from a specific offset and are allowed to read from any offset point they choose. The permissions. We use IAM permissions on operation to get to use specific instructions such as list, get, update, create, and delete streams. Next slide, Simon. Yeah, thank you. So there are different benefits of streaming, which are so streaming has several advantages over traditional messaging queues. They are configurable message persistence. So what do you mean by that? It controls how long data is retained. Messages in a stream are available for the entirety of the stream's configured retention time. Replay. Stream messages are not removed immediately when processed by consumers. You can replay any and all messages in the stream anytime within the configured retention time. Message guarantees. Each message is guaranteed to be delivered at least once. In some cases, such as consumers, failure to commit messages before going offline, messages are delivered multiple times. Order guarantees. Message within a stream or partitions are always delivered in the same order that they were produced. Client-side cursors. Client applications track which messages are read and move the cursor as needed for the maximum flexibility. Horizontal scaling. Partitions provide an opportunity to scale up the throughput to meet the needs of multiple consumers, resulting in increased flexibility. Consumer groups. Consumer groups handle all the coordinations that is required to deliver messages to multiple consumers in a balanced manner. Because this management is handled by a consumer group on behalf of all its members, you can reduce overhead and operational ease. Next slide, Simi. So what are the different use cases of streaming? So let us look into that. The first one is high throughput message bus. So streaming service is an idle for microservices and other applications that require high throughput and low latency data movement. And here streaming services can guarantee you for this service. Real-time analytics engine. So feeding data at scale from website or mobile apps or data warehouse or monitoring systems or analytics engines, real-time it takes the data. So real-time actions helps ensure developers can take this action. Integrations with Oracle database and SaaS applications. So what do you mean by this is you can integrate OCI streaming to ingest applications and infrastructure logs for Oracle SaaS applications such as eBusiness Suite, PeopleSoft, Change Data Capture, CDC, logs from Oracle databases. You can use Apache Kafka connectors for Oracle Integration Cloud and then transport those downstream systems to Oracle Object Storage for long-term retentions. Next slide, Simi. So what are the different ways to access streaming? So let us look into that. The first one is Oracle Cloud Infrastructure REST APIs. It provides the most functionality, but requires a little bit programming expertise. API reference and endpoints provide endpoint details and links in the available API reference document, which we can easily get it from Oracle's document. The streaming service is accessible with the streaming API, and developers have the flexibility of either using Apache Kafka APIs or Oracle Cloud Native Streaming APIs, which are available for most of the SDKs such as Python, Java, TypeScript, and Go. The next is Oracle Cloud Infrastructure SDKs. So software development kit. So it enables you to interact with streaming without having to create a framework. So basic streaming usage examples are included in the SDKs and you can find them on Oracle official document. The next is command line interfaces. So CLI command. So it provides both quick and easy and full functionality without the need of programming, which we are going to show a small demo of CLI also. The next one is OCI console. So it is an easily used to browser-based interface. So you can just go on the browser and then create and manage stream pools and Kafka Connect configurations. Next slide, Simi. Okay. So managing streams. So how do you manage a stream? So we need to create a stream before publishing messages to a stream or consuming messages from a stream. So in order to do that, you have to use Oracle Cloud Infrastructure Console or streaming APIs to create the stream. And when creating streams, we need to consider the following: expected stream throughput, message retention period, partition key strategies, and how the streams will be consumed. We'll discuss them in the next slide. So you can configure the number of partition in the streams based on the following considerations. The first one is throughput. So throughput. So while creating a stream, you must specify how many partitions of the stream has. The expected throughput of the applications can help determine the number of partitions from the stream. Multiply the average message size by the maximum number of messages written by second to estimate the expected throughput. Since the single partition is limited to 1 MB per second write rate, higher throughput requires additional partitions to avoid throttling. Keep additional partitions limit in mind while making the decision. The second one is publishing. The content of the message you intend to publish to a stream can also help to determine how many partitions or a stream should have. A message is published to a partition in a stream if there is more than one partition. The partition where the message is published is calculated using the messages key, and messages with the same key go with the same partition. Next one is consumer group. If a stream has been consumed by one or more consumer groups, consider this while deciding on how many partition it should have. Partition reads are balanced among the instances in the consumer group. Consumer groups can use only a single instance at a time. If the stream has only one partition, and if the stream has multiple partition, consider scaling the number of instance up to the number of partition and have one instance in the group reading from one position in the stream. Stream pooling. So stream pooling service uses a default pool to contain the streams. If you don't create a stream pool, the default pool will be assigned. Stream security. Streaming data is encrypted at rest and in transit. So private endpoints within the virtual cloud network is used to restrict the access to the streams. So it cannot be accessed throughout the internet. And private endpoint IPs associated within a VCM to the stream pools allow streaming traffic to avoid traversing to the internet. To create a private endpoint for streaming, you need to have a VCN with a private subnet when creating a stream pool. Next slide. So there are different IAM policies which we require. So let us understand what policies are required for managing streams. So to use Oracle Cloud Infrastructure, you must be granted security access in a policy by an administrator. This access is required to use console or REST APIs or SDKs or CLI or any another tool. Below are the few policies which needs to be initiated if you want to manage the streams. Those are: allow group stream admins to manage streams in a tenancy, allow group stream users to use stream push if you want to push the data, if you want to pull the data. These are the policies which are used. Next slide, Simba. So next slide is about stream pooling. So what do you mean by stream pooling? So stream poolings are logical groupings of streams. So every stream needs to be a member of a stream pool. Streaming service uses a default pool to contain the streams. If you don't create the stream pool, so there is no limit for the number of stream pools to be created, and stream must be unique within the stream pools. Stream pools serve as a root of virtual Apache Kafka cluster when using Kafka with streamings. All the streamings within the pool share the same Kafka configurations, encryptions, and access control settings. Every action on the virtual cluster is scoped to that stream pool. The stream pools are used to organize streams into groups matching organizational structure or a specific solution. It restricts access to a specified virtual cloud network, VCN, inside the tenancy so that the stream pools are not accessed throughout the internet. It also specifies whether the data in the pool streams should be encrypted using vault encryption key or Oracle managed keys. Next slide. Publishing messages. So what do you mean by publishing messages? So let us look how to publish messages also. So once a stream is created and active, users can publish messages. A message is composed of a key and a value, and it is published on a single partition in the stream. In case of less than one partition, the partition where the message gets published using streaming API put messages depends on the message's keys. If producers are using streaming APIs, partition is handled server side by the streaming services. If producers are using Kafka APIs, partition is handled in the client side by Kafka. Okay. The next slide is about handling large messages. So how do you handle large messages? So if messages are larger than 1 MB limit, use the following techniques to send the messages. The first one is chunking. So in chunking, we split the large payload into multiple smaller chunks that the streaming service can accept. The chunks are stored into the service in the same way that the ordinary non-chunked messages are stored. The only difference is that the consumer keeps the chunk and combine it into a message when all the chunks have been collected. The chunks in the partition can be interwoven with ordinary messages at last. Next one is OCI object storage. So a large payload is placed in object storage, and only the pointer is there in the data which has been transferred. So the receiver recognizes the type of pointer payload and transparently reads the data from the object storage and provides it to the end users. Next one is batching and throttling. So recommended messages batching for the following reasons. Reduces the number of put requests sent to the service, which avoids throttling, enables better throughput, and the size of a batch of messages shouldn't exceed more than 1 MB. If the limit is exceeded, the throttling mechanism is triggered, and the throttling mechanism for put messages is activated, which writes exceeds 1 MB per second per partition. The next one is consuming messages. So let us look out how to consume messages. It is used to consume a message from a stream. So consuming messages requires the following: creating a cursor, then using the cursor to read the messages, using the returned cursor to continue reading the messages, use an individual cursor to read messages from one or more streams, or use consumer groups to read messages from the stream. So you can look at the screenshot where we produce the message and when we can consume the latest messages from the console whenever the message is produced. Next slide. Okay, so consuming messages have different terminologies which we'll look into. So the first one is a cursor is pointed to a location in a stream, and the location should be at a specified offset or a time in a partition. In general, consumer subscribes to one or more topics and reads the messages in order in which they are produced. Consumer keeps tracks of which messages it has already consumed by keeping track of the offsets. There are 5 types of supported cursors which are there in this PPT. The first one is trim horizon. So what do you mean by trim horizon? It starts consuming from the oldest available message in the stream. It creates the cursor from trim horizon and consumes all messages in a stream. Next one is at offset. So it starts consuming at a specified offset. So the offset must be greater than or equal to the offset of the oldest message and less than or equal to the latest published message. After offset, start consuming after the given offset. So there is this cursor has the same restriction as the at offset cursor. At time, start consuming from a given time. The timestamp of the return messages will be on or after the supplied time. Latest, start consuming messages that were published after you created the cursor. Next slide, Sanmi. Yeah. So what is a consumer group? A consumer group is a set of consumers that coordinate to consume messages from all partitions in the stream. Each partition is consumed only by one member of the group. So consumer group handle the coordination that is required for multiple consumers who share the consumptions of a stream. A consumer group automatically assigns one or more partitions to an instance and tracks the messages received from the group and manages commits, requests proper partition and offsets on behalf of each instance. It balances the group as instance join or leaves. So it does the rebalancing also. So when streaming receives a request from a message from an instance, the service checks to see whether a group rebalance is necessary. It commits the offsets from the instance previous request, if any, and responds within the message defined for the requested cursor. Next slide, Sami. So there are different design considerations which we need to check before creating a stream. So let us look at them. The first one is OCI streaming supports messages retention up to maximum 7 days. So maximum message received supported is just 1 MB. Each partition can handle up to 1000 emit API calls per second and 5 read API calls per second. Each partitions can support up to a maximum total data write rate of 1 MB per second and a read rate of 2 MB per second. Each tenancy have a limit of 5 partitions. Yeah. So let's jump into the streaming demo. Simi, you can stop sharing and I'll share my screen. Let me know if you can see my screen.
Yes, we can see the screen.
Okay, thank you. So we log into the OCI console. I'm logging via my credentials. Okay. So I'll tell you about how to create a stream pool, create a stream, then delete a stream, move a stream from a different tenant, move a stream from one compartment to another compartment. I'll also show you a small demo about creating a stream via CLI and via SDK. So once we log in, we reach to this home page. We need to go to the burger menu over here and we need to go to analytics and AI and click streaming. So once we reach over here, we need to select the compartment where we want to create the stream pools. So I have my compartment and I'll select my compartment over here. So the first one is we need to create a stream pool. So to create a stream pool, you just go to the stream pools over here and create a stream pool. You give a name to the stream pool. You can give it as a demo stream pool. You need to check the resource compartment. And as I've told you in the slides, we need to select the public endpoint or private endpoint. So public endpoint, you can have access via internet. Private endpoint, you won't have access via internet. And then the encryption key, whether you want Oracle to manage the encryption keys or you have the customer managed key. I'm keeping this as default and then I'm going to create. So I've created a demo stream pool. It takes a couple of seconds to create. Meanwhile, I'll show you to create a stream. Yeah, the stream pool is active now. I'll show you how to create a stream. So to create a stream, you just go to create stream and give demo stream the name of the stream. You need to check the compartment again, and you need to select which stream pool you require. So the one which was created last, I'll select the same one. So I can see a demo stream pool. If you don't give a stream pool, it will select default stream pool. Then the next is we need to give the stream setting. So how much retention time. So 24 hours maximum hours we can give is up to 168. We can give number of partitions, and it's 1 MB and 2 MB. The write rate is 1 MB and the total read rate is 2 MB per second. And we then create the stream. So it takes a couple of seconds to create the stream also. In the meanwhile, I'm just starting the Cloud Shell. It takes a minute or so. I'll explain the shell part a little bit later. So I've just started. You have to go to a Cloud Shell and I have to create. So now, if you want to produce any message in the stream, you have to you just have to go over here in the stream and then type a message like, this is Masterclass 1. And I do produce. So this message has been produced now. If I do it 2, and this is produced. So it's showing success. And if you want to consume any message and you want to see the latest messages, you just click on this and you will be able to see the key and values. So this masterclass and the offset. So this is how you produce and consume a stream. So the next one, I'll show you how to create a stream and stream the stream pool via CLI. The first command is OCI streaming. So this is the command OCI stream admin stream pool. This is to create a stream pool. You have to give the name of the stream pool. So I'm giving the name as stream pool CLI. You have to give the compartment ID. To get the compartment ID, you need to go to identity and security and go to the compartment. And once you go to this compartment, you have to select whichever compartment you require. So my compartment name is MV Bhopal. So I go to this compartment, I copy this and I paste this key or OCI ID over here. Once I do this, a new streaming pool is created. You can check the streaming pool again, going to the same page. So a new stream with the name stream pool underscore CLI has been created. Now the same way we have to create streams also. So the next one is to create a stream. What I'll do is again these commands are all there on the OCI documentation page also. So what you do is OCI streaming admin stream, you create, you give the stream name, you give the how many partitions you require, and again the compartment ID and the compartment ID where you want to create it. And once we do this, a new stream has been created. So it's getting created. Streaming underscore CLI is getting created. The next thing is to get stream information. So if you want to get the information about the particular stream, then you can, the command to do is this one, OCI stream admin stream get stream ID. So we go to the stream, which is already created. We show this and we copy the stream ID and we paste it over here, and we'll get all the definitions, all the parameters of this particular stream, such as the compartment ID, the defined tags, the namespaces, then the life cycle state, the message endpoints, the partition, how many partition it has, the retention in hours. So basically the whole information about the stream. The next one is to list all the streams. So if you want to list how many streams are there in the compartment, this is the command. So OCI streaming admin stream list. I give my compartment ID again. And when I click this, all the streams which are there in the particular compartments will be listed. The next one is to get the stream pool information. So the way we took stream streams information, we can do it for stream pool information also. So we go to OCI streaming admin, stream pool, get stream pool ID. So to get the stream pool ID, we go over here, we again go to stream pool and we go to stream pool CLI. We copy this and we paste it in this, and then we'll get the stream pools information, the same like stream pools streams information. So there will be different tags which will get like the Kafka settings also will get the lifecycle state, the lifecycle details, the name, the private endpoint settings, everything. We'll get the complete information about it. The next one is we need to produce a message. So you need to create a file and have a content in that file. I've already created the file to save time. So so this is the file. I have generated key and value pairs. So these are the keys and these are the default data which I want to produce. So this so I want to publish this into the stream which is there. So how to do this? So to produce this message, you go again you just copy this command and you copy the stream ID where you want to produce it. You give the location of the file which you want to produce. So it's in the JSON format. So I have given the location of the file, and then I have to give the endpoint details. So the endpoint details can be found out from the console itself. So this is the endpoint details which I need to give. I copy this endpoint and I paste this endpoint, and when I hit this, the message will be produced. So to consume this messages, we need to hit one more CLI command, and that is OCI streaming cursor stream. Again, we'll place this ID of the stream, and then the one is we need to give on which partition and what type of cursor we need to specify. So we have given partition 0 where we need to consume it, and the type of cursor. So here we are giving it as trim horizon, which we have explained the different types of cursors. And once that is done, we'll give the endpoint. So endpoint is the same thing where we copy from the console, and we copy this endpoint. Just 1 second. It's not getting copied.
Mitesh, time check. It's all going to be 11. It's already 11:42.
I'm sorry. Just 1 second. I'm just copying it in the meanwhile doing it in the text box because it wasn't getting placed. So this is, yeah. So the message has been consumed now. Now to get that messages, you have a different command named as OCI stream messages get stream ID. Again, it's the same thing. You place the stream ID, copy the stream ID, and then again the endpoint details. We need to provide the cursor also over here. So the cursor is the value which has been there. So we need to copy the whole value. And we need to provide the endpoint again. So this is the endpoint which I copy, and again I placed it over here. So you can see this message has been published. The one which was there in the file text. So this message has been consumed. It is published successfully and consumed. The next one which we are going to discuss is about the SDKs. How to publish messages via SDKs. So to do that, there's a Python readily SDK code which is available on the Oracle documentation. You just need to utilize that code. So I've already created a stream underscore example.py file, and it has all the code to write the produce the message, to create a new stream pool, and write the messages and consume the messages. So to run this code, it's a simple code. You just need to hit this and give the the compartment ID where we want to produce that code. So once we do that, the compartment ID is the one where we want to produce launch this Python code. So once we do that, it will create the whole SDK partitions for us, like the stream pools, the streaming API, the streaming APIs, and it will start producing 100 values, and it will consume also the 100 values. So stream SDK has been already created now. So it is producing those messages. So if you load those messages, you'll be able to see those messages. Yeah. So this is the whole demo which I wanted to show you. So Simi, can you just share your screen again?
Doing that. Does it work?
Yeah, it is. Okay. So we'll talk about what is Apache Kafka. So let's have a brief introduction of Apache Kafka. So Apache Kafka is an open source distributed event streaming platform used by thousands of companies for high performance data pipelines, streaming analytics, data integrations, and mission critical applications. Apache Kafka was originally developed by LinkedIn, and later it was donated to Apache Software Foundation. Currently, it is maintained under Confluent under the Apache Software Foundations. So here you can see the Apache Kafka architecture. So let's deep dive into and understand the architecture of Apache Kafka. So the graphic shows there are 4 components, which are brokers, zookeepers, producers, and consumers. So brokers. So Kafka clusters typically consist of multiple brokers to maintain load balance. So Kafka brokers are stateless. So they use zookeepers for maintaining the cluster state. So one Kafka broker instance can handle up to thousands of read and write data per second. And each broker can handle TB of messages without performance impact. Next is Zookeeper. So Zookeeper is used for managing and coordinating Kafka brokers. So the Zookeeper service is mainly used to notify the producers and consumers about the presence of any new brokers in the Kafka system or failure of a broker in the Kafka system. As of the notification received by the Zookeeper regarding the presence of failure of a broker, the producer and consumer take a decision to start coordinating that task with some other brokers. The next is producers. Producers push data to brokers. So when a new broker is started, all the producers search it and automatically sends a message to a new broker. So the Kafka producers does not wait for acknowledgement from the broker and sends messages as fast as the broker can handle. Next is consumers. So Kafka brokers are stateless, which means that the consumer has to maintain how many messages have been consumed by using partition offsets. If the consumer acknowledges a particular message offsets, it implies that the consumer has consumed all prior messages. The consumer issues an asynchronous pull request to brokers to have a buffer of bytes. The consumers can rewind or skip any point in a partition simply by supplying the offset value. And the consumer's offset value is notified to the Zookeeper. So next slide, Simi. So here in this slide, we can see the difference between the OCI streaming services and Apache Kafka services. So the OCI streaming service is an it's an Oracle managed multi-tenant, and it provides REST APIs and publishes and consumes messages using put and get request. In Apache Kafka, it is a customer managed dedicated instance and it provides the native APIs. So that is a major difference where we notice. Next slide. Streamings with Apache Kafka. So let us understand how streaming works with Kafka. So streaming uses Kafka Connect ecosystem to interface directly with external sources such as databases, object stores, or any microservices on Oracle Cloud. OCI streaming allows users of Apache Kafka to offload the setup, infrastructure managing, and host your own Zookeeper and Kafka clusters are required. Streaming is compatible with most Kafka APIs. It allows to use applications written for Kafka to send messages and receive messages from streaming services without having to rewrite the code. Kafka connectors can easily and automatically create, publish to, and deliver topics while taking advantages of streaming services, high throughput, and durability. Next slide, Simi. So what are the different use cases of using streaming and Kafka? So following are the use cases. Moving data from streaming to autonomous data warehouse to perform advanced analytics and visualization. Using the Oracle Golden Gate connector for big data to build an event-driven applications. Moving the data from streaming to Oracle Object Storage for long-term storage or to run Hadoop or Spark jobs. Next slide. So we'll talk about streaming metrics and give an overview of it. So what are streaming metrics? The streaming metrics provides metrics which shows how the service is performing. These metrics are default and automatically available. So the streaming metrics are used for the following: understanding the produce or consume latency for a real-time application, calculate and validate the price of service usage, monitor changes in throughput over time, and check the time that the last message was consumed. Next slide. So what do you mean by stream health? So let us look into that. So if a stream is active, which means the messages are getting received and consumed successfully. If get message API calls the returns elevated levels of an internal server error, the service is not healthy. A healthy stream also has healthy metrics. So these are the different metrics which we need to check. They are put messages through total throughput is close to 1 MB per second per partition. Put message latency is low. Put message throttle records is close to 0. Put message failure is close to 0. Get message latency is low. Get message total throughput is close to 2 MB per second per partition. Get message throttle request is close to 0, or get message failure is close to 0. Next slide, Simi. So if there is any spike happening, then you can set up an alarm. So these are the following parameters where we can consider setting alarms for producer metrics. So first one is put message latency. So if an increase in latency means that the messages are taking longer to publish, which could indicate network issues. Put message total throughput. So an increase in latency, increasing total throughput would indicate that 1 MB per second per partition limit will be reached, and that the event will be triggered for throttling mechanisms. A decrease could mean that the client producer is having an issue or is about to stop. Put message throttle records. It is important to get notified when messages are throttled. So you can put an alarm for that. Put message failures. So if the message starts failing, then we can generate an alarm for that. To set up an alarms for consumer metrics, we can use it for get message latency, get message total throughput, get message total throttle request, and get message failures. Next slide, Simmi. So there are different troubleshooting mechanisms, troubleshooting mechanisms which are been recorded. Some of the few issues which are related to Oracle Cloud Infrastructure streamings are been displayed over here. The first one is request returns a processing exception while communicating message and a -1 error. So this error is related to client. The streaming service doesn't send it, which means that the request never made it to the service. Request returns not authorized or not found message and a 404 error. So this error means that the needed resource isn't found, or that you don't have access to it. Any example in which the stream push policy is missing, the stream has been deleted or is not accessible, ensure that the permissions are correctly set to mitigate this error. The next one is request return. Request size is limited to 1 MB message and 400 error. So this error means it occurs because the put message call sent to the service is too large. The size must be less than or equal to 1 MB. Stream creation fail with you exceed the number of allowed partition messages. So this error occurs when you try to create more partitions that your tenancy is allowed, and you cannot create or increase. Consumer receives a cursor is outside the retention period and is now valid message 404 error. The last one is the request fail with an unusable past JSON body message and a 404 error. So these are some of the errors which have been recorded, and we can mitigate them. Next slide, Simi. Okay. So lastly, there are some of the resources and the links which will be made available to you via email after this sessions. Simi will send you the following email along with the link of the video recording. So in case if you have missed something or have any additional questions, you can reach out to me and a team, and I would definitely answer your queries over email or if possible Zoom call. This is pretty much from my side. Next slide. Yeah. So to get certified, we have a new OCI training free certification available to 31st December for all the startups. So the startups which are there in our SQ, our default can enroll this certifications. Next slide, Simmi. So once you log into the Oracle Cloud Infrastructure console, you can directly go to the get started with free training, and you can utilize these free trainings. Next slide. So that there are different trainings which are available, and you can use this to clear the courses and clear your doubts. So there are OCI Foundation Associated Certificate. This is the basic level certificate. The next one is the Architect Associate certifications, and Architect Professional Certification, Operation Certifications, and the last one is the Database Specialist Certification. So you can avail all these certifications free of cost till 31st December. You can use this free training links available to check the labs and get OCI certified. Yeah, thank you, Simi. Over to you.
Good. Thank you, everyone. And we have already mentioned the email ID. You guys can reach out to us, and thank you again for taking time and being here today. I see that question and answers were taken by our team. And if you have any further questions, don't hesitate to reach out to us. And we will be sharing the link discussed in the session and all the related documents to you. I hope you found this session good, and we would love to hear back from you. Have a great rest of the day. Thank you, everyone.
Thank you. Bye.